Yeah, I know. Yeah, she was telling me about it. All right, are we about done or stuck? Stuck. All right, in graph or in equation lowercase a, what's the negative out front of the parentheses going to make my graph do? Everybody. Reflection, not over y, reflection over x. So it opens upside down. What's the -2 on the inside of the parentheses going to make it do? So it opens down and went right to. Which one is it? D. Okay, so that one is graph D. So we use that one. Okay, let's look at equation B. What's the -2 on the inside of the parentheses going to make it do? Right to, and then the +2 on the outside. Which one is that? C. Okay, it went right to, up to. So that one's done. Now let's look at equation C. The negative out front is going to make it reflect over x. +2 on the inside is going to make it left 2 and down 2. Which graph is that? A. Okay. Now, 0.5 on the outside. That one threw us a little bit. What's the 0.5 on the outside going to make it do? Vertical compression. Because it's okay. So it's going to get wider. And then it's going to go which other ways? Right 2 and down 2. Which one went right 2, down 2, and looks like it maybe got a little bit wider? F. Okay. How about this next one? What's a 2 on the outside going to make it do? Vertical stretch, so it's going to get narrower. And then what's the -2 on the inside going to make it do? Right 2. Which one is E? B? Oh. And then how about F? Let's just double check. The only one that's left is E. Did it reflect over X? Did it go left 2 and down up 2? Yes. Okay. How do you guys remember those a little bit? Yes? Okay. So let's talk about when you have an equation in what we call vertex form, which we'll talk about later, but this is vertex form. The A tells us a couple different things. If it's negative, it tells us if it reflects over X. If it's bigger than 1, it's a vertical stretch. If it's less, between 0 and 1, it's a shrink or compression, vertical shrink or compression. Now, inside, H tells us how much we go left to right. If it's -H, it goes which way? Right. If it's +H, we went left. K tells us how much we go up or down. If it's +K, we went up. If it's -K, we went down. So hopefully all of that you remember from before. Same with all of this, okay? I have all of this not on your sheets because we've talked about this before, and we just talked about it a few minutes ago. So let's just go straight to an example. Describe the transformations and then graph the function, okay? Graph each function. So let's talk first about what the transformations are. So what transformation happened on this graph? Let's go with Chloe. Okay, she says it goes left 4 because it's +4 and down 1. Perfect. Now let's graph our parent function. I'm going to do that in red. What is -2 squared? What's -2 times -2, Chloe? 4. What's -1 squared?
1.
What's 0 squared?
0.
1 squared?
1.
And 2 squared.
1.
So these are the 5 key points I want you to have on your graphs. Now you're going to take each of those 5 key points and you're going to shift them which way? Left 4 and
Down 1.
down 1. left 1, 2, 3, 4, down 1. And here's my new graph. Okay, so the red one is f of x. The blue one is g of x. So I really don't have anything new to teach you. That you've done. Have you done that? Yep. Okay. Let's look at another one. Am I going too fast or are we good? Good? Okay. Describe the transformation, graph each function. So now what's happening? Let's look at A. What is the negative out front going to make it do? Ty. Okay, so the negative out front, he says it reflects over the x-axis. And then what's the 1/2 going to make it do?
Vertical compression by 1/2.
Vertical compression by 1/2. Is everybody good so far? Or vertical shrink, either way. Now, Ty, let's graph our 5 key points for the parent function. You're going to go -2 what?
4.
-1,
1.
0,
0.
1, 2, 4. So this is my parent function. This is f of x. Now, here's how I do this. You could, if you wanted to, put it in your graphing calculator, look at your table of values. Remember when you go to your graphing calculator, you have to turn your plot off. I'll show you in 1 second how to do that. I think it's easier just to do it by hand sometimes, okay? This point 4 is going to come down here to what? -4. This comes to 1. -1, that's 0, that goes to -1, and that goes to -4. Do you see how the green points just reflected it over the x-axis? Flipped it upside down. The hard part is a vertical compression by 1/2. When I do a vertical compression by 1/2, am I affecting x or am I affecting y? Y, right? Okay. So you're affecting y. So all you do is take your y coordinate and multiply it by 1/2. So my y coordinate was -4. What do you get when you multiply it by 1/2? -2. This was -1. What do you get when you multiply it by 1/2? -1/2. It was 0. What's 0 times 1/2? 0. This was -1. Multiply it by 1/2. This was -4, multiply it by 1/2. And this is my new function, g of x. Is it g? Yeah. Okay. Now, if you don't remember how to do that, let's go to our graphing calculators real quick. Okay. And in your graphing calculator, you can go to y equals. Now, this is important. When you are graphing your statistics, with your list, your plot has to be on. You're going to go up, go down, come over. Turn your plot off. All right. Now we're going to put -1/2. So I always put my fractions in parentheses because sometimes you have to, sometimes you don't have to. I always do, and I'm never wrong. -1/2. X, remember, is next to the second function, x. And then I'm just going to do squared, which is the 5th button down on the left. Now, if I press graph, the last graph I did was a scatter plot, and I did zoom 9, so it fit to whatever statistics I have in my calculator. Zoom 9 is zoom stat. What zoom do I want for this one? Do you guys remember? 6. So the 2 zooms you guys will use the most. Zoom 6, which is standard, -10 to 10 by a scale of 1. And zoom stat will fit to whatever's in that list. So I'm going to do zoom 6. And then to see my table, I'm going to go second table. And I'm going to go up so I can see at -2, I had -2. At negative 1, I had negative 0.5. At 0, I had 0. 1, negative 0.5, and 2. What's wrong? Okay, so close your parentheses. Go back over. Close your parentheses. X squared. Zoom 6. And then second graph. So, okay, anybody else need help with this? What? Error. Okay, go to you're number 2. Oh, well, that's right. You didn't hit number 2. Did you use a minus sign instead of a negative? You see the difference? Now we're at. All right. Anybody else? Everybody else good? Again, guys, I think that's almost a little more time. All right, calculators down. I don't want you using your calculators. Put them down for a minute. Let's look at example B without your, I don't want to see calculators. Okay, what are we going to do? Jack, what is happening here when you have a 2 on the inside? Careful, is it outside with the x squared or is it inside with just the x?
Horizontal.
Okay, now remember horizontal, you got to flip it, so it would be not by 2, but by
1/2.
So it wouldn't be a stretch, it'd be a horizontal shrink by 1/2. Do you guys see how we reason through that? Okay, do you guys see the difference between A and B? Vertical stretch or vertical compression by 1/2, horizontal shrink by 1/2. It's in with the X. And then, Jack, what's the +1 on the outside going to make it do?
It's just going to make it go up.
1. Perfect. So we described the transformations. Now help me graph the parent function. At negative 2, you go up what?
Up 1.
What's negative 2 squared?
4.
Okay. What's negative 1 squared?
1.
What's 0 squared?
0.
What's 1 squared?
1.
And what's 2 squared?
2.
Not 2.
4.
4. Okay. And there's your parent function. So there, those 5 points need to be there. Now, guys, the horizontal shrinks can be very difficult. So for this one, I am just going to go to my calculator. Make sure you have parentheses 2x on the outside squared plus 1. So make sure on this one you have parentheses 2x, parentheses squared on the outside plus 1. Now, I already did my zoom 6, so I can just go to graph. It'll stay at that window. I'm going to go second table. And did you guys get numbers like -2, 17? So I'm like way up there because it got pushed together so much. At -1, I had 5. At 0, I had 1. At 1, I have 5. And at 2, I'm way back up there again. So does it look like it was horizontally shrunk? Like someone took and put those together horizontally and shrunk, pushed it together?
Wait, what numbers did you get in your family?
I got -2, 17, -1, 5. I'm looking. I'm looking here. Did you not get those, Mitch?
No.
God, you hate your computer, don't
Did you
you?
get numbers? Oh, I just did my life.
It's on the top right.
Yep. Yep. Graph. Second table. Now, okay, scroll up. Just you can't see. Yep. There you go. It's all right. We got it. Just so you guys know, just so I can show you in case this happens to anybody at home, his computer, his calculator was like this. You couldn't see the negatives. So you just have to scroll up like this. You can scroll around until you can see other pieces and other parts of your graph. Okay? Questions? How do you guys feel so far? Good? Okay, we have 2 more, and then you guys can start your homework.
Yeah, Glenn.
Okay? Let the graph, now guys, we have done these. These are on your test. The only difference is now you got to tell me what the vertex is. Okay, let the graph, and do these in order, be a vertical stretch by 2. Okay, we're taking the parent, f of x equals x squared. So Laura, you're taking the parent function, and you're going to do a vertical stretch by 2. What do you do when you do a vertical stretch by 2, Laura?
Don't we just like put it on the outside?
Yep, so 2 times x squared. Is that a vertical stretch by 2? Sure is.
Okay.
Now you're going to do a reflect over x. What do you do when you reflect over x? Negative 2x squared. Because remember, when you reflect over x, you change y. Y is the whole equation. All right? By the way, when she did a vertical stretch and a reflection over x, has my vertex moved?
No.
Not yet. Now, Laura, go down 3. What do you do when you go down 3? Okay, she says just subtract 3. Now, most of you will just write it up there as one step. Since these are my notes for the video, I put it down there. Subtract 3. Now, what's the vertex? Okay, we already talked about it. We said vertical stretch, got skinnier, reflect over x, opened upside down. Didn't change my vertex. But now when I went down 3, did that affect my vertex? Yeah, so now my vertex is down here. I'm skinny and open down. So what is my vertex? Careful, it's a point. It's a coordinate point. Over 0, down 3. Done. So just like you had on your test yesterday, clean up each step before you go on. I feel like I said that so much, I still have kids not do that. Okay, ready? Parent function, starting here. Horizontal, shrink by 1/3. Horizontal, shrink by 1/3. Page. Okay, parenthesis 3x, parenthesis squared. She said she's going to make all of her x's become 3x. Horizontal, flip it. Horizontal affects x, 3x. Now, clean it up, Paige, before you go on. What do you get when you square 3x? 9x. Yeah, I had one person in this class, when they squared it, they forgot to bring the square down. They made a U go, made it a line. Careful, okay? All right, now a reflection over y. So now, Paige, when we reflect over y, what changes? Which one do you change? Okay, you change x. So now you're going to come in and say, okay, 9, and now x becomes what? Negative x squared. Now, does it affect it at this point? What's negative x times negative x? X squared. So you just, when you clean it up, have 9x squared. Think about this. All I did was took this and did a horizontal shrink. And then when I reflected over the y-axis, it just went, is it the same thing? Yes. Okay. Now what are we doing? Lastly, we're doing up to. What do you guys get when you go up 2. 9x squared what? Questions there. Okay, you have the rest of class time to get started on this homework. 2 through 10 even, 16 to 22 even, 25 and 26. Yes, you have to graph.